Hi, my name is Ripan. Today I will walk you through the paper Cross-lingual reasoning through test time scaling and share a possible improvement. So the central idea is large language models can be given more thinking tokens at test time, but the effect isn't uniform. Sometimes extended reasoning help, but sometimes it hurts as well, especially in multilingual settings. So the core problem is, uh, can we improve reasoning across multiple language simply by scaling test time compute? That is allowing basically longer research reasoning chains. This is important because cross-lingual performance is a bottleneck in LLM, often better when English, but in other language, and scaling compute might bridge the gap. Then this paper basically showed that longer reasoning budgets boost performance in for larger models. For example, a model with more than 3 billion parameters in STEM-heavy tasks, but in certain domains like medical QA or medical QA, overthinking lowers the accuracy. That is, we call model drifting or hallucination. In cross-lingual setting, reasoning in English often transfers better than reasoning directly in the native language. That might be a low resource language, but the benefits depend heavily on the token budget. So more compute helps sometimes, but not universally. So my takeaway is from the paper is, instead of relying on fixed reasoning budgets, for example, the paper showed three fixed tokens, 500, 4,000 and 8,000 tokens. But I guess this is two digits. Some problems need longer reasoning chain and some might need shorter reasoning chain. So, and also in cross-lingual tasks, the optimal budget often depends on the domain and the language. So instead of fixed budget, we need adaptive test time compute. Then my proposed solution is we can probably do a short probe chain of thought, probably from 64 to 128 tokens. Then we can feed this to a smaller controller, maybe a logistic regressor or a tiny transformer or even a bandit. The controller decides one of the four actions. It can stop reasoning. It can extend by a possible number of tokens. It can switch reasoning language, and also it can trigger a verification step. For the reward, we can use a lambda flop with lambda adjusted to domain specific. For example, if it is a STEM domain, we can probably we can probably use a higher lambda. This way, the model learns to think when to think more and which language to think to at the same time. My evaluation plan is, instead of using fixed token budget, we can we can use the fixed token budget as a baseline, and we can do some weight exploration strategies. Then for metrics, as I've said, we'll use lambda flop, and we can probably calibrate the stop rules and percentage of tokens that were saved from the baseline. Then finally, this paper shows that the test time scaling improves cross-lingual reasoning, but blindly adding tokens can backfire. My proposal is to an adaptive policy that decides dynamically how to think and in which language to think. This could make LLMs more efficient, reliable, and human-like in multilingual problem solving. Thank you.